All right, let's do a limiting reactant practice problem. So here's the situation. Let's just say that 127.84 grams of sodium nitrate react with 111.73 grams of copper 2 sulfate in a double replacement reaction. After that reaction takes place, 129.44 grams of copper nitrate are produced. So we're going to pretend that this actually happened in a lab setting, and we actually produced 129.44 grams of this particular product, copper 2 nitrate. Okay, so the question is this, which is actually a 5-part question, and that's pretty normal for something like this. You're going to write the equation, determine the limiting reactant, find the theoretical yield, and then the percent yield, percent error, and then determine how much of the excess reactant is left over. So let's just start with A, writing the balanced chemical equation. So we have sodium nitrate, which is NaNO3. This is a +1 to -1 oxidation ratio, so that's a good compound. Plus our copper 2 sulfate, Cu and SO4. That's also a +2 to -2 oxidation ratio, so that's a good formula. And we produce, in a double replacement reaction, sodium sulfate, Na and SO4. Now we have a +1 to -2 oxidation ratio, so we need to subscript the sodium with a 2. And our other product here is the copper 2 nitrate. So that's copper and nitrate. This is a +2 to -1 oxidation ratio, so we need to subscript our nitrate with a 2. Okay? So that's the unbalanced equation, and let's go ahead and set forward to balance this. You can go through the bookkeeping method if you need to, or if by now you can just do it in your head, that's fine. I'm just gonna do it quickly here. Sodiums are 2, we need a 2 here. 2 sodiums, 2 sodiums, 2 nitrates, 2 nitrates, 1 copper, 1 copper, 1 sulfate, 1 sulfate. Good. So this just balanced easy enough with a 2 coefficient right here. Okay? So step A, done. B, determine the limiting reactant. Oh boy, so this is where the work starts, right? So I think the best thing you can do at this point is to calculate the molar masses of these compounds and write them beneath the symbols here, or beneath the chemical formulas, because you're going to use them all in this problem. So I've done this already. This is 85.00 grams per mole. This is 159.62. Sodium sulfate's 42.05, and copper 2 nitrate 187.57. Okay, so those are the numbers, those are the molar masses of those compounds. So remember, in a limiting reactant problem, what we want to do is basically define one of the reactants as chemical A and the other as chemical B. And then we're going to see if all of chemical A, which I'm going to make this one here, and this one chemical B, if all of the sodium nitrate reacts away, how much copper sulfate would it require to make that happen? And so we do that with dimensional analysis, gram to gram stoichiometry. So let's go ahead and plug those things in here. Our starting amount of chemical A is 127.84 grams. The molar mass of that sodium nitrate compound goes here. 1 mole goes here. The molar ratio goes here, so the 2 to 1 ratio. The 2 is coming from this sodium nitrate 2, and then the 1 is coming from the 1 coefficient that you can't see but is there. And then here we're going to do the molar mass of compound B, 159.62, and that's 1 mole. Okay, and let's do the math here. Times 1 times 1 times 159.62 divided by times 2. Okay, so that's 120.03. And that's grams of chemical B, CuSO4, required. So to react away all of the starting amount of sodium nitrate, it would take 120.03 grams of copper sulfate. This is now where we compare that amount of copper sulfate required to the amount of copper sulfate that we've been given in the problem. And this is from a previous video. And remember this, if more of chemical B is required than given to you in the problem, then B is the limiting reactant. And if less of chemical B is required than given in the problem, then A is the limiting reactant. So let's see where we're at with that. So we require more of chemical B than we have been given. So that means that B is the limiting reactant. So copper sulfate is our limiting reactant. Okay, good. All right, so that is B. All right, so B is done. We've determined the limiting reactant is copper 2 sulfate. Okay, so now on to letter C. Determine the theoretical yield of copper 2 nitrate. So remember that when we find the limiting reactant, the production of our product is completely dependent on the amount of limiting reactant that we have in the problem. So again, we're going to do a gram-to-gram stoichiometry problem. And this time for chemical A, we're going to use our limiting reactant, which is copper 2 sulfate. And the amount of that given to us is 111.73 grams. Its molar mass is 159.62. 1 mole. The mole ratio between our limiting reactant and our product that we're asking about here is a 1-to-1 ratio. That's nice. And then the molar mass of that chemical B, which is the copper 2 nitrate, which we're asking about, that is 187.57. Okay. So this calculation is going to give us the theoretical yield of copper 2 nitrate based on a limiting reactant. So we'll do the math on that. Times 1 times 1, that's good. 187.57 divided by, yeah, nice, 159.62. Okay, so that gives us a theoretical yield of 131.29 grams of CuNO3 2, okay? So that's our theoretical yield. And the theoretical yield is going to be used against the actual yield from the problem to solve the next portions of these problems, which is step D, which is what is the percent yield and the percent error in copper 2 nitrate production. So remember, let's do the yield first. Remember that percent yield is the actual over the theoretical times 100. Okay, so let's take our actual production, which is given to us in the problem. That's that number right there. That's 129.44 grams divided by our theoretical production, which we've just calculated in the previous part of this problem, 131.29 grams. We're going to multiply that fraction by 100, and that's going to be our percent yield. 129.44 divided by 131.29 times that by 100, and that gives us a 98.591%. That is a good yield. That means that basically, according to what we should have produced, we produced pretty much all of what we should have produced, minus a percentage and a half or so. And that's what our percent error is going to be. So remember now that when we do their percent error, we take our actual minus our theoretical absolute value of that difference if need be. and we're going to divide it by the theoretical and then multiply it by 100. Okay, so let's do the math on that. That means our, I'm just going to write these numbers in here. 131.29 minus 129.44. I've got these, I always put the bigger number first so I don't have a negative number. And then we're going to divide that difference by the theoretical yield, which we calculated here, 131.29, and multiply that by 100. And that should give us our like 1.5% or so. So let's we'll do the math here. That gives us 1.85, good. 2 decimal places, good. Divided by 131.29 times 100. Yeah, and that gives us our 1.41% error. Good, okay. So again, when you underproduce, then the difference from the yield to 100 will be your percent error. But do the math just to do it right. Okay, and then the last part here is E, and E is how many grams of the excess reactant remain unreacted. Okay, so that. Again, we're going to be comparing how much of the limiting reactant got used to how much of the excess reactant needed to get used. And so here we're still going to use our copper sulfate as our limiting reactant. And we're going to see how much sodium nitrate gets used. So we started with 111.73 grams of our copper sulfate. It's got its molar mass of 159.62, 1 mole. And then the molar ratio between our two reactants, if our limiting reactant is A, then its coefficient goes here. And 2 is going to go up here, right? The 2, that's for the sodium nitrate, that's chemical B. And then sodium nitrate's 85.00 grams per 1 mole goes here. And let's see how much sodium nitrate we actually use along with all of the copper sulfate. We used 118.99 grams of the sodium nitrate. So that's the amount of sodium nitrate that got used. And remember, you got to go back to the problem again here to remember how much of it you had to work with. We had 127.84, and of that we only used what we just calculated, 118. So we can just take our starting amount of sodium nitrate, 127.84, and then we can take away the amount that we used. So this is the amount we started with, and this is the amount we used, and the difference between these is the amount that is left over and unreacted. So 127.84 minus 0.99 again equals 8.85 grams. Of sodium nitrate are left over, okay? So quite a bit of math and quite a few problems to do in one big problem. So that is one example problem, and I hope that helps.